Assalamualaikum warahmatullahi wabarakatuh. My name is NH.halina binti HABIB. My matrix number 2022 844944.
Assalamualaikum warahmatullahi wabarakatuh. My name is ATIKAH binti ISMAIL. Matrix number 2022-844246.
My name is NURIN binti SAIFUL AMIRUDIN. My matrix number is 2022898646.
Hi, my name is NURIN SUFI binti SAIFUL ANUAR and my number matrix is 2022-856516.
Assalamualaikum warahmatullahi wabarakatuh. I am NURUL binti NASIR and my matrix number is 2022-881928. Thank you.
You guys know what is HABIB? HABIB stands for what kind of meaning? So let me explain to you. So HABIB stands from hazard analysis and critical control points. So HABIB such a management method that addresses food safety by analyzing and controlling biological, chemical and physical hazard from raw material until the distribution process, which means that if we want to make one product, so HABIB focus on analyzing which one of the process in potential to be hazard, like biological, chemical or physical hazard. So has also such a critical document since developed in accordance with hazard principle. So currently hazard control in the food chain according to Malaysian standard 1490 2019. So HABIB employs two methods hazard analysis, which are detecting hazard and critical control points. So what is critical control point? So critical point which mean that along the process from start until the end of the process, which process that inclined to be critical control point that we need to do and such a significant process that we need to do a corrective actions or any kinds of correction we need to do that with that critical control points. Okay, for the second, to measure to avoid food safety risk and lower the risk to unacceptable level. Our company profile. So our company's name is SUFI Sweet Enterprise. So our company established since June 2021, currently located in Johor. So our company is focusing on the productions of processed fresh food in Malaysia, but specifically based on Johor Bahru, since our headquarters in Johor. So our initial product is sweet kernel cone, which we think want to produce and expand ready to eat product, especially for people who doesn't have much time to cut the cones one by ourselves. So besides, we also ensure for delivery high quality processed fresh fruits of our products. And in addition, our productions also of this product follow the Malaysian standard, such as good manufacturing practice and HABIB in our company. So this we think this as a great step to get customer loyalty and trust of our product in long-term purchase.
Okay, next I will share about our product description. So the firstly is the ingredient. The first ingredient that we use to produce our product must be corn as the main raw material, and the other ingredients such as sugar, salt and water. And the other ingredient that we use, do not harm the people, the consumers' health at all, unless if the people have an allergy to corn, so they should avoid to consume our product. Our product is intended for general public consumption and it's a ready-to-eat food. For example, the recipe that I can share using our product sweet kernel corn is the salad wrap. Okay, so the consumer just open the lid and put the corn on the wrap and it's done. But if anyone wants to eat just like that, you can too, and no worries, it's easy to eat and the taste is good. The consumer doesn't need to worry because our product can last up to 3 years if the lid is not open yet. But if it has been opened, the consumer needs to keep in the fridge only 3 to 4 days. If keep too long, exceed the prescribed instruction, the texture will be viscous and cannot be consumed anymore. Then we store our product in the warehouse and we have set the appropriate temperature, which is the 29 degrees Celsius for our base canned product. Okay, lastly is the important thing is the traceability code. The traceability code that we put on our product is date of manufacturing, expiry date, and storage code, so that it is easy for us to trace our product if there is any problem later.
Referring to the process flow diagram of our company, let me explain one by one for the processing step, including firstly, the process of receiving. Our company received the cone from our supplier, which is LC Maiz Manufacturing Sendirian Berhad. In this process, the cone that were received are expected to be a significant hazard since it was naturally occurrence by the pathogenic bacteria such as Clavibacter nebraskensis that are naturally found in the cone. Besides, there were also chemical hazards that are produced by specific fungi that can develop on agricultural products named mycotoxins. Thus, it was also considered as a significant hazard. Further physical hazard in the process of receiving the cone, soil, sticks, or might be stone can be found due to the excessive harvest process. The second step is storing. In this processing step, the cone must be stored in a low moisture content so that it will be safe from biological hazards such as endospore that might be found on the cone. Hence, it was classified as a significant hazard for that reason. Besides the biological hazard, during the storing process, the temperature abuse can cause the fungus to grow, which also categorized as a significant hazard. Various from physical hazard, pest or insect infestation might be happen during the storage process, which eventually can cause cross-contamination towards the cone. Next, the third step of our processing are washing the cone thoroughly with clean and flowing water. The pathogenic bacteria on the cone still remain there, since the washing process cannot even eliminate the bacteria that are naturally occurrence on your material and also double up by the abuse of the temperature. Thus, it might be a significant hazard based on our observation. Furthermore, there is no chemical hazard arise through this processing step, but for the physical hazard, it seems to not likely occur as it can be controlled by GMP program. The fourth step is grading. The cone will be graded into a high, moderate, and low quality of cone. In this processing step, there is totally no significant hazard from biological, chemical, and also physical hazard. Other than that, the fifth processing step of our sweet kernel cone is blanching. This step involves scalding the cone in a boiling water or steam for a short time, intense 50s. During this process, biological hazards still exist because it was originating from natural environment and temperature abuse during the transportation that can cause the multiplication of pathogenic bacteria. It was then categorized as a significant hazard. Along with this, there is also chemical hazard, namely enzyme catalase and peroxidase that are naturally occur in fruit tops, otherwise can cause loss of flavor, color and texture of the cone. Moreover, the sixth processing step is mixing all the materials needed to make a canned cone. Mixing process are not classified as a significant hazard because of the not likely occurrence of mold contamination since it can be controlled by good manufacturing practices GMP. In addition, there are also no significant hazard for chemical since the sanitizing chemical use must be checked of its residual chemical to be safe for cleaning program. Next, the seventh step is scanning the cone into the aluminium can. This step seems not have any issue regarding those three categories of hazard. Nevertheless, it still have the possibility to be occurred by the contamination or residue of chemical from aluminium can, but it can be controlled through the GMO so that it was not considered as a significant hazard. Additionally, the eighth processing step is sealing the can to make it secure by using machine. In this step, there is no significant hazard either from biological, chemical, or even physical hazard. The ninth step is sterilization. The can cone will be sterilized to completely eliminate all form of microbial. If these steps are not performed well, pathogen bacteria can grow due to the time temperature abuse, so that it will be classified under the significant hazard from biological aspect. Besides, during the sterilization process, the leakage of cans might be happen due to the excessive cooling process, but it was not categorized as a significant hazard as long as it can be avoided.
A further processing step in order to make our product is a cooling process. In this process, it might have the appearance of germs which categorized in biological hazards in order to ensure the safety of the product. These germs can survive under high temperature. So because of that, we need to eliminate this hazard significantly by ensuring the temperature of can was in a perfect rate, or we can just add some time of cooling process time. And furthermore, the metal detection process is one of the physical hazard that will appear in this process flow, which is the corrosion of iron sheet. And we need to reduce this by using a trace machine and doing some inspection to ensure the hazard was eliminated perfectly. Along three process forward, which is packaging and labeling, storing, and distribution, which is has the hazard in the same category, that's physical hazard. This can be occurred by implementing good manufacturing practices (GMP) when handling the products. And now we're moving forward to the CCP, which is critical control point that can be located at any step where hazard can be either to prevent it or eliminate it or even reduce it to acceptable levels. So in the sweet kernel corn production, we identified there's three CCP, which is CCP first at the blanching process, where the existence of chemical enzyme we call catalase and peroxidase. And the second CCP detected in sterilization process in form of biological hazards such as pathogenic bacteria. And lastly, CCP3 was in the metal detection process, which is the presence of metal shard itself state was in the category of physical hazard.
In this section, I will present the critical limit available at three critical control points. The first critical limit occurs at critical control point first, which is the blanching process. The critical limit here is to set the appropriate temperature, which is in the range of 55 to 75 degrees Celsius, and each worker practices process procedures that comply with good manufacturing practices (GMP) to avoid contamination. At this first critical limit, we will monitor the temperature and obey the GMP guideline. The temperature will be measured using a special temperature tool and practicing GMP. The frequency of monitoring CCP first is done on each batch of sweet kernel corn products, and this monitoring will be done by the operator. For corrective action, the rejected product will be held and the blanching process will be repeated with the temperature rate that has been set based on GMP. Next, the second critical limit is at the second critical control point, which is the sterilization process. For the critical limit CCP2 is to ensure the sterilization period and temperature above critical limits 116 to 121 degrees Celsius, attainable with pressure cannons operated from 20 to to 100 minutes, which means it takes about 1.5 hours. At this CCP2, we will monitor the time and temperature throughout this process. To measure the time and temperature, we will use an industrial stopwatch and measure the temperature from the commercial sterilization temperature. The frequency of this monitoring is carried out on each product batch and is monitored by the operator. We will take corrective action if the product is below the critical limit time and temperature. We will desterilize the products until it reaches the critical limit. And the last critical limits in CCP3, which is in the metal detection process. The critical limit of this process is the absence of metallic components. In this process, we will monitor the sensor of the metal detector, PLC and alarm. We will monitor using a test piece, and this monitoring will be done at the beginning of production and every 1 hour interval during the production time. This monitoring will be handled by the operator. As for the corrective action for this process, we will reject all non-conformed products and rework the products.
In conclusion, Jupi Sweet Enterprise use the HACCP system to ensuring the food and product we serve to customer is secure and free from any possible physical, chemical and microbiological risk. And we believe that HACCP system give one of the most effective and efficient way to increase the food safety in the food service sector. Consequently, it has a positive effect of the reputation of our business. HACCP also improve the trade in food products and guarantee the safety of food supply and lowers the risk of incident for the foodborne illness. And finally, we hope that Jupi Sweet Enterprise can successfully implement HACCP in order to improve the safety of food control for in present and the future.